Okay, in this video we're going to take a look at a temperature problem. Again, a fever is generally considered to be a body temperature that is greater than 100 degrees Fahrenheit. And your friend calls you from some other country and says, hey, my temperature is 37 degrees Celsius on their thermometer, and wants to know, do you think that that's a fever? Well, so what we would have to do is convert this into Fahrenheit. So we go back to our formula. Fahrenheit is 9/5 of the Celsius plus 32. And so we need our calculator, and we bring that up. So 37 divided by 5 is 7.4 times 9 is 66.6 plus 32, and we get 98.6 degrees Fahrenheit, and you tell your friend you're fine. Alright, so that's an example of converting using our two formulas listed in black up in the top right hand corner there. Okay, in the next example we're going to work with simple interest, and simple interest has the formula I equals P times R times T. And so where I is the interest that you're going to earn, principal is P is the principal, which is the amount of money that you are depositing or putting into an investment. Rate is the interest rate that you're going to get back from it, and T is the time in years that you are investing your money. So let's read the problem. You invest $5,000 in an account that earns simple interest. After 6 months, the account earns $162.50. What is the annual interest rate? So we start with, we know that the interest in the end, here we have I is equal to $162.50. We also know that we're depositing $5,000, so that's the principal, P. And after 6 months, what's important here for the time is that you have to count this in years. So we're not going to put 6 there, rather we're going to put 0.5, because that's 1/2 of a year, and we don't know what the rate is, and that's what we're trying to figure out here. So at this point it's okay for me if you were to just start with your formula. I equals P times R times T, and let's plug in what we do know. 162.50 is equal to 5,000 times 0.5 times R, and half of 5,000 is 2,500 R. 162.50, so we're going to divide by 2,500, divide by 2,500, and using my calculator again, there we go. We clear that out, and we're going to divide 162.5 by 2,500, and that's equal to 0.065, which means, or 6.5% is the annual interest rate there. 0.065. Remember, to get the percent from a decimal, we're going to move the decimal place 2 places to the right. Alright, let's see what else we have in this. A lot of different formulas for things in this section. And we'll scroll up and look at another one. Okay, so in this problem, we have a truck driver averaging 60 miles per hour while delivering freight to a customer. On the return trip, the driver averages 50 miles per hour due to construction. The total driving time is 6.6 hours. How long does each trip take? Now I would use with this one what we have been using all along for distance problems, and we'll see that this structure can be used in other ways. besides distance, but we have distance is equal to rate times time. And so going and coming back. So the first row is going to be going and coming back in the second row. Now let's see what we do know. We do know that going, he drove 60 miles per hour. Coming back, 50 miles per hour. Now we only know that the total driving time was 6.6 hours. So do we know how long? First of all, we do know that on each way the distance is the same. So the way we're going to solve a problem like this is as follows. If we know the total driving time was 6.6 hours, so what would happen if going up it took him 3 hours? Then to find the time coming back, we know that the total time was 6.6, so we would just subtract 6.6 minus 3 and we would get 3.6 hours coming back. I hope that makes sense. We know the total time. Now if we knew how long he spent going, we would simply subtract 6.6 minus how much time he already took up, and that would be how much time is left. Then again, we do know that the distances are the same in each case, so we would end up with two equations. D is equal to 60x and D is equal to 50 times 6.6 minus x. We know that those are equivalent, so we set them equal to each other. 60x equals 50 times 6.6 minus x, and we're ready to begin. We distribute on the right side 50 times 6.6. You can use your calculator. And when we do, we end up with 330 is minus 50x is equal to 60x. Just be careful here when you isolate the variable, you're adding 50x. Adding 50x, so we'll have 110x is equal to 330, dividing both sides by 110, and we will get that x is equal to 3. And what does x mean? X is in the time column for going, so 3 hours going. Actually, I guessed it right. I think I guessed it right on the dot there. So then coming back, we've said is 6.6 minus x, or 6.6 minus 3 would be 3.6 hours coming back. And that was a pretty good guess. I literally did guess that as an example. So hopefully this makes sense, and we're building on what we know about the distance equals rate times time problems. And we'll stop this and go on to another video. Actually, I'm going to continue. We have 2 more quick examples here, and then we'll get into the homework. So we'll finish these up and in this video and go on. So again, here we're working with interest. Recall your formula. Interest equals principal times rate times time. How much money must you deposit? So how much money must you deposit? That's referring to principal. So here we say principal, we don't know. In a simple interest account, to earn $500 in interest, so I is equal to 400. In 5 years, that's time, and at 4% interest rate, again, we're going to write that in decimal form as 0.04, which we need to do in order to multiply this all out. So we set up our equation. 500 is equal to P times R, which is 0.04, times t, which is 5, and we get 500 is equal to 0.04 times 5 is 0.2, 0.2 p. To solve for p, we would have to divide by 0.2, and so the principal that we would need to invest, get our calculator, 500 divided by 0.2 is $2,500. We would need to invest in order to get an interest rate of 4%, an interest of $500 for 5 years at 4%. We'll stop here and go on to another example. Okay, in this example, a truck driver averages 60 miles per hour while delivering freight, 45 miles per hour on the return trip. The total driving time is 7 hours, so we're going to set up our structure. Okay, so going, coming back, we have distance equals rate times time. Going was 60 miles per hour. Coming back, 45 miles per hour. The entire trip took 7 hours, so we don't know how long it took him going, but we're going to subtract that from the 7 to get what's left on the return trip, and so we have, again, the distance is exactly the same in both cases. So we have 60 times x, d equals 60 times x, and d equals 45 times 7 minus x. We set them equal since we know that the two distances are the same. 60x is equal to 45 times 7 minus x. And we have 7 times 45. 7 times 45 is 315. So we would have 315 minus 45x is equal to 60x. Remembering to add the 45, not subtract, gives us 105. X equals 315. Dividing by 105, we get that x is equal to 3. What is that? That's 3 hours. That's the going time. Then 7 minus 3 is 4 hours. Is the return time. Very good. Okay, so that's going to do it for this video, and we will go on to homework in the next.